Namaste students, I am Shobha, Science faculty from Mangala Vidya Mandira. Today, let us start the next chapter, that is chapter 10, Combustion and Flame. So let us learn more about this combustion and flame in this chapter. So before going to the chapter, we use different kinds of fuel for various purposes at home, isn't it? Even in industries and even for running our automobiles, we use different types of fuels. Can you name some of the fuels which is used in trades and industries? What fuels are used for running automobiles, students? Can you guess? Yes, if you start listing it down, so will contain the fuels like cow dung, wood, coal, charcoal, petrol, diesel, compressed natural gas, that is CNG, etc. So these are all different fuels which we are using it for different purpose in our day-to-day life. You are familiar with the burning of candle. What is the difference between burning of a candle and the burning of a fuel like coal or charcoal? You may be able to guess. Yes, so candle burns with a flame, whereas the coal does not burn with the flame. So let us study this chemical process of burning and the types of flames which has been produced during this process. So that is what we call it as combustion. A chemical process in which a substance reacts with oxygen to give off heat is called combustion. The substance that undergoes combustion is said to be combustible or combustible substance, which is called as fuel. The fuel may be of solid, liquid or gas. Sometimes light is also given off during combustion, either as a flame or as a glow, which we already know, like a burning of a candle where the light will be given off as a product of combustion. Let us do an activity to learn more about this combustion and its combustible fuel. Collect some materials like straw, matchsticks, kerosene oil, paper, iron nails, stone piece, glass, etc. under the supervision of teacher. Here we can't help you, so take the help of your parents and try to burn each of these materials one by one. If combustion takes place, mark the material as combustible. Otherwise, it is marked as non-combustible. Can you name some more substances which are combustible? So, you have to try to collect as many as you can with all these substances and try to ignite them, and you just see whether they are undergoing combustion or not. So after doing this activity, please record in your project books. So again, we'll continue with some more activities. So all these activities are considering with the flame and combustion. So it should be taken care with under the supervision of your parents. So first activity 2, let us go for the first part. Fix a lighted candle on a table. Put a glass chimney over the candle and rest it on a few wooden blocks in such a way that air can enter the chimney. Observe what happens to the flame. Now, second thing what we have to do is, now remove the blocks and let the chimney rest on the table. Again observe the flame. Third case what we have to do, finally put the glass plate over the chimney and watch the flame. So we are doing 3 different activities. So one with chimney, another one chimney with small openings with the help of the blocks, and the third one completely covered with the plate above the chimney. So in each of these cases, students, if you try to observe in all the 3 cases, whether it was flame was there, or if the flame was there or smoke was there. If the flame was there, was it flickering? Flickering means it will be shaking. So does it affect any burning process? So if you have tried this activity, we can conclude or we can come to an observation that if we find that of the three combustion process, we can first notice is air is necessary. This is a basic thing which we have already learnt in our earlier basic classes, where for combustion air is one important necessary thing. The candle burns freely in the case when the air can enter the chimney from below. But in this case B, that is in the second case, when the air does not enter the chimney from below, the flame starts flickering and it produces smoke. So if it flickering means it starts shaking, it is going to turn off. Once it is not completely burnt, when the combustion does not takes place completely, you get that smoke. In the third case, when it was being completely covered by the glass plate, finally the flame goes off because it will be not having any air which is needed for the combustion. So from this activity we can clearly see that air is necessary for combustion, that is especially oxygen. So next we can do another one more activity where we have to take a piece of burning wood or charcoal and keep it on an iron plate or iron tawa. Cover it with a glass jar or a tumbler or with any transparent plastic jar, but be careful while you use the plastic jar, it may start melting if it is having little bit contact with that burning wood or charcoal. Observe what happens. Does the charcoal stops burning after some times? Can you think of the reason why it stops burning? Okay, you might have guessed. Okay, do this experience tell you that different substances catches fire at different temperature? This wood and charcoal will be having a different temperature where it could have started burning, but when it has been completely closed with a glass tumbler or something, so it is having some minimum temperature where it starts to catches fire. That minimum temperature or the lowest temperature at which the substance catches the fire is called as ignition temperature. We find that the combustible substances, that is like fuel, cannot catch fire or burn as long as it reaches the ignition temperature. So different combustible substance, that is different fuel, is having different ignition temperature, students. So all the fuels will not start burning or it does not catches fire at the same temperature. You will have different temperature, that is ignition temperature for different fuels. So that is what, as I told, what is ignition temperature means the lowest pressure at which the substances catches fire is called as ignition temperature. We find that a combustible substance, nothing but a fuel, cannot catch fire or burn as long it's having lower than its ignition temperature. Once it starts reaching the ignition temperature only, it starts catching the fire. Kerosene oil and wood do not catch fire on their own at room temperature, but if the same kerosene oil is heated a little, it catches fire. In the same way, if the wood is heated little, it would still not catch fire. Does it mean that ignition temperature of kerosene oil is lower than that of the wood? Yes. So kerosene oil's ignition temperature will be very less compared to that of the wood. For wood, we have to provide still more extra heat so that it starts to catch fire. So the following activity will show that it is essential for substances to reach ignition temperature to burn. So that is what the activity what we have taken. We have to take 2 paper cups, students. I think so everyone will be having paper cups. You can even use the used paper cups also, and pour 50 ml of water in one of the paper cups. Another paper cup, keep it empty. Start heating both the paper cups separately with the help of the candle. What happens to the empty paper cup and what happens to the paper cup which has been filled with water? Can you just guess, or you just do the experiment and you can observe whatever it will be told now. If you continue eating the cup, we can even boil water in the paper cup. Can you think of the explanation of this phenomenon? That is what, students, the empty paper cup would have easily catched fire, and it could have started burning, and even it could have turned into ash. But the paper cup where it was being filled with water does not catches fire. Why it is happening? Even if you try to eat continuously also, even you can see the water in the paper cup starts boiling, but the paper cup will not get burnt. So why is this happening? This is because the heat supplied to the paper cup is transferred to the water by the process of conduction. So in the presence of water, the ignition temperature of the paper cup is not reached, hence it does not burn. So from this activity it is clear that different substances, that is combustible substances, has different ignition temperature. Next, what are these inflammable substances? This word you could have seen on many of the trucks carrying the petrol and petrol related products from one place to another place. You would have seen inflammable, highly inflammable. So flammable, inflammable. So inflammable means what? The substance which have very low ignition temperature and can easily catch fire with the flame are called as inflammable substances. For example, petrol, alcohol, LPG, etc. all are inflammable. Inflammable means the substance can easily catch fire. So only they would have written on the tankers, oil tankers and all, highly inflammable means it will be easily able to catch fire. Why it will easily catch fire? Because its ignition temperature is very less. So then how to control fire? If at all, if some fire accident happens, how to control this fire? So before going to the different measures to control fire, let us see what are the things we required for the combustion. Already we have discussed. In this picture you can see there is an fire brigade, that is a fireman, usually what you will call. He has arrived, and what he is doing, he pours the water on the fire. What does this water do? Water cools the combustible material so that its ignition temperature is being brought very less. This prevents the fire from spreading. Water vapors also surrounds the combustible material, helping in to cut off the supply of air. So the fire is extinguished, that is, fire is put off. The three main things, students, what we have to remember is any of the fire extinguishers what we do, there should be something which cut down the substance which help in combustion. So like see, there are three important requirements for producing fire. Any type of fire we require three things. One is fuel, that is combustible substance. Other thing is air, and the third thing is an ignition temperature or ignition heat. So if these three things are there, so easily one can start to a fire. But if you want to put off the fire, so out of these three things you have to cut down one of that. So when you cut down one of it, so easily you can put off the fire. So fire can be controlled by removing one or more of these requirements. The job of the fire extinguisher is to cut off the supply of air, or it has to cut down the temperature of the fuel, or both. So you have to select the fire extinguishers which will do both of this or any one of this. So there are different types of extinguishers. The most common fire extinguisher is water. But water works only when the things like wood and paper are on fire. If electrical equipment is on fire, water may conduct the electricity, and those will harm the person who is there and external also. So water is not suitable for all fire accidents which is involving it is electrical appliances and oil and petrol. So all if it oil, petrol and electrical equipments, if catches fire, we should not use water as an extinguisher. It is only meant for paper and wood. So you can just recall whatever you have studied in your lower classes, different type of fire extinguisher. So it sinks below that, the oil and the oil keeping burning on the top. For fires involving electrical equipments and inflammable materials like petrol, carbon dioxide is the best fire extinguisher, because carbon dioxide is heavier than that of oxygen, so it will not allow the oxygen to go and contact with fire. So carbon dioxide takes the place of oxygen, and it's a good fire extinguisher. So this is the one. First one is water, second one is carbon dioxide. So apart from this, as we can continue, since the contact between the fuel and the oxygen is being cut off by the carbon dioxide, the supply of oxygen to the fire will be cut off and the flame will be put off. Now let us come to different types of combustion. There are three important types of combustion, students. One is rapid combustion, one is spontaneous combustion, and the third one is explosion. So I will see each and everything with the help of an example. So first one, burning a matchstick or a gas lighter and bringing it near to the gas stove in the kitchen. Turn on the knob of the gas stove. What do you observe? We find that the gas burner rapidly starts producing heat and light. So this type of combustion is called as spontaneous, quick combustion. Sorry, it's not spontaneous, it is called as rapid combustion. Rapid, instantaneously it happens, that is rapid combustion. So another type of combustion is spontaneous. What is the spontaneous combustion? There are different substances like phosphorus, which burns in the air at room temperature. Even though you are not providing it some minimum heat, they in themselves starts catching fire. Example, phosphorus, sodium and all, when you keep it under room temperature, it starts burning on their own. So this suddenly burst into flames without the application of any external cause. This is called as spontaneous combustion. The spontaneous combustion of coal dust has resulted in many disastrous fires in coal mines. The spontaneous forest fires are sometimes due to the heat of the sun or due to the lightning strikes. However, most forest fires are due to the carelessness of human beings. It is important to remember that the campfires must be completely extinguished before leaving a forest after a picnic or a visit. Hope you have understood what is the difference between rapid combustion and spontaneous combustion. The third type is explosion. We generally have fireworks on festival days during Diwali and all. So when a cracker is ignited, a sudden reaction takes place with the evolution of heat, light and sound. A large amount of gas formed in this reaction is liberated, and this type of reactions or combustion is called as explosion. Explosion can also take place if the pressure is applied on the crackers. So these are the three different types of combustion. Now let us move to the second part of our chapter, that is flame. So everyone would have seen flame, right? So the most common flame you would have observed is LPG flame. Can you tell me the color of the flame? What are the colors of the flame you have seen? And you would have seen the flame of a candle also. So will be the color of the flame in the candle and the LPG will be the same. So you just see, or if you have observed, you can just recall, or if you have not observed, just go and see how the flame of an LPG is there and how a flame of a candle is there. There will be little bit difference. So let us do this activity before we go for the other parts of the flame. So light a candle. So usually it is available at home. So light a candle. Hold a glass tube, that is a tube which is made up of glass, with a pair of tongs, and introduce its one end to the dark zone of non-flickering candle flame. Dark zone means the middle zone of a candle flame. Bring the lighted matchsticks near the other end of the glass tube. So one end of the glass tube is near the candle's flame. Another end of the glass tube, we have to ignite it with the help of a matchstick. So do you observe the flame in both the cases? You can try doing this if you are having a glass tube. If so, what is that flame produced? So will it be the same, the color will be the same whether it is near the candle or the matchsticks. So if you try to do this activity, we will observe this following. When the candle flame is steady, introducing a clean glass tube into a luminous zone of a flame. Luminous means darker, means brighter, very thick zone of the flame for 10 seconds. It forms a blackish ring around that glass tube or glass, whatever the glass material we would have taken. It indicates that the deposition of unburnt carbon particles present in that luminous flame. Holding a thin copper wire just inside the flame for about 30 seconds, you will get that reddish hot on that glass rod. So glass rod or glass tube, you will get reddish hot color. So this shows this is the hottest part of the flame. So middle part where it is thick, there will not be so much hot, whereas the topmost part, very thin part, you will be having hottest temperature. So after going through this experiment, we can summarize that. So the structure of a flame, so we just go through the help of a candle flame. So it is having three parts: the least hot part, moderately hot part, that is the middle part, and the hottest part, that is the top tip part. So where the innermost part, where you can see that black color residues and all, the middle one will be yellowish in color, and outer zone which is completely undergoing combustion, either it will be in blue or orangish in color. So this is the structure of the flame. So next, coming to this fuel, as we have seen in the first part, the fuel is very important for combustion. So let us go through the what is fuel and the different types of fuel. So these fuels are being used in many domestic and industrial purpose students, like wood, charcoal, petrol, kerosene, etc. These are commonly called as fuels. A good fuel is a one which is readily available. So it is available for each and every person immediately. It should be cheap. It burns easily in the air at a moderate rate. It produces a large amount of heat. It does not leave behind any undesirable substance, and it should not give us a large amount of smoke. There is probably no fuel that could be considered as an ideal fuel. So we should look for an fuel which fulfills almost this requirement. So whatever the above said points are the characteristics of an ideal fuel or a good fuel. But still now such a fuel is not available which is having 100% efficiency. So either 95% efficient fuel is available, but not 100% fuel that is readily available. It is cheap, in a cheap amount it gives a good quality, and the quantity is good. So if a fuel is having all this character, then you call it as an ideal fuel. So what is the efficiency of a fuel? So efficiency means how best it can perform. So that is called as fuel efficiency. Suppose you were asked to boil a given quantity of water using a cow dung, coal and LPG as a fuel. Which one you prefer, students? Obviously, it is LPG. So why we have preferring LPG means, so the amount or the quantity of the heat produced by LPG is more compared to the quantity of the heat produced by coal and charcoal. The second thing is, coal and charcoal is not available exclusively everywhere, and also the time taken for burning process is also little bit slow compared to LPG. So based on this, the amount of heat energy produced on a complete combustion of 1 kg of fuel is called as calorific value. This calorific value of a fuel will be different for different fuels, and it will be expressed in kilojoule per kg. So LPG is having more calorific value, so we will be preferring, or that is being considered as an efficient fuel compared to the other fuels. So if a fuel is being used, we know different products which is obtained after combustion. So they will be leading to many harmful substances. We'll discuss one by one. So especially these fuels, whatever we are speaking, almost are made up of carbon. So carbon fuels like wood, coal, petroleum releases unburnt carbon particles, which will be either in the form of carbon monoxide or carbon dioxide, which is highly dangerous pollutants causing respiratory diseases like asthma. Secondly, this incomplete combustion of these fuels gives carbon monoxide gas. It is a very poisonous gas. It is dangerous to burn coal in a closed room. So always burn, if at all, if you are forced to burn the coal, burn it in an open space. The carbon dioxide may also can kill the person who is sleeping in that closed room. Third thing is, most of the fuels releases carbon dioxide, which increases the global warming. The next one is, burning of this coal and diesel releases another one harmful gas, that is sulfur dioxide gas, which is highly suffocating and corrosive gas. Moreover, petrol engines gives off this gases of nitrogen dioxide, very again another dangerous gas, which is a main cause for the acid rain. So it is very harmful for the crops, buildings and soil. So global warming, acid rain, greenhouse effect, so all these are the results of this harmful products which are released during combustion. So we have to first select good quality of fuel which will be releasing very less harmful product to the environment. So apart from this, as I told, global warming, and another one is deforestation. In order to get this wood, coal, charcoal and all, we have to cut down the forest. So another environmental issue because of this combustion process. Another one, as I discussed, it is global warming, which is nothing but the rise in the temperature of the atmosphere. So as a result, the polar glaciers are melting and the sea levels are being increased. So low-lying coastal areas are being permanently submerged into water. So land area is becoming less, the water area is becoming more. So we have to reduce the use of this petrol and diesel fuel automobiles and replace it by a natural gas, that is CNG, compressed natural gas, where it is comparatively producing less harmful product and it is being considered as a cleaner and eco-friendly fuel. So this is an activity, students, where you have to do and you have to present it in your project books. That is an fire extinguisher. You have to create a model of fire extinguisher where you have to take a short candle and a slightly taller candle, comparatively both should be comparative, and place these two candles filled with baking soda. Baking soda is normal cooking soda what you use in the kitchen. Place the dish at the bottom of the larger bowl. So there is a larger bowl, inside that smaller bowl. Inside the smaller bowl you are having baking soda. Inside that baking soda you have kept two candles of comparable size and light both the candles. Then you have to pour vinegar into the dish of baking soda. So baking soda is a base, vinegar is an acid. Be careful, do it in an open condition. Do not pour vinegar on the candle. You should be very careful. You should pour only on the baking soda. Observe that foam starts forming. So what happens to the candle? Why? And you have to write the principle which is involved in that also. So this you have to write it in project book. Hope you have understood this chapter, students. Thank you.